Hey, welcome to my channel. In this video, we are going to discover the Firebase Realtime Database rules. Rules are the most important part of the security of your database because they decide who has permission to access or update each part of the data in your database. Real-time database rules have a JavaScript-like syntax and come in 4 types. Read describes if and when data is allowed to be read by users. Write describes if and when data is allowed to be written. Validate defines what a correctly formatted value will look like, whether it has a child attributes in the data type. Index on specifies a child to index to support ordering inquiry. Since most of the Firebase-powered apps run code on the client side, they have to enforce their own security kind of approach for more protection. This approach works in 4 steps. The first step is authentication, which means that users have to identify themselves before they get access to some critical part of the database. The second step is authorization, which means that not every user has the ability to reach each single part of the database, even if they are authenticated. The third step is data validation, which means that if a user has the right privilege, they still have to either provide the data in a certain form or it will be refused. The final step is defining database indexes, which is more related to the performance of your app. Okay, that said, let's get started with the structure of the rules. Basically, rules should have the same structure as the data and the database, except that in the values we have conditions. If a condition evaluates to true, that means access is allowed. On the other hand, false means access is not allowed, and that's pretty much it. If you created a new database, your rules should be like this, which means that nobody has access neither to write or read data from it. Let's run a test and see that in action. This is the code implemented for reading and writing some pieces of data in the database. By the way, if you don't know how that works, make sure to watch my Firebase Realtime Database on the client side first, so you can follow. As you can see, I got a permission denied message when I tried to save data. So that said, let's change the right rule and see what will happen. Now data can be saved. Let's try to do the same with reading data. Permission denied. Let's change the read rule. And now it works. This is just for testing purpose, so do not add rules to the upper level or so-called root of your database, because with the rules I have now, everybody can read and write in each part of my database. Along with the rule types, we have also a few of predefined variables to set the different conditions of access. Now, the current time in milliseconds since Linux epoch. This works particularly well for validating timestamps created with the SDK's Firebase Database Server Value Timestamp. Root, a rule data snapshot representing the root path in the Firebase database as it exists before the attempted operation. New data, a rule data snapshot representing the data as it would exist after the attempted operation. It includes the new data being written in existing data. Data, a rule data snapshot representing the data as it existed before the attempted operation. $symbol variables, a wildcard path used to represent IDs and dynamic child keys. Auth represents an authenticated user's token payload. Okay, let's start by creating our first rule, which imposes that a user can't write data unless they sign into the app, which leads us to use the auth predefined variable, which itself contains a UID property. So, if the UID is null, that means the user hasn't authenticated yet, so they can't write to the database. If it's different than null, that means that the user is signed in, meaning that they have the right privilege. Every time a user creates an account on your app, they get a unique ID representing their account, called UID. So, if I authenticate to the app using a Google account, as you can see, a UID has been attached to the account. Simulator is a very helpful tool that you can use to keep testing with different rules with less effort and less time. Let's make a reading test and see what we will get. Permission denied since we didn't add the read rule, so let's add it and run another test. Now, let's try another condition to the reading rule from the user's reference, which imposes that a user has to be signed in first to be able to read. As you can see, the simulator provides different simulation types and ways of authentication in order to make the work way easier. Let's create another rule using another predefined variable, which is data. With this rule, we are imposing that in order to write data, a user has to be authenticated, and the user's reference should already contain data. Let's delete everything from the user's node and see if the authenticated user still can write data. Let's try another rule. In this one, we want each user to be able to read their own data only. And to do that, we need to use the $symbol variable or wildcard. The $user work in the same way as the parameter in the for each loop in JavaScript, which means that the $user will be filled with the key of each user and apply the rule for each user in the node. And the rule here is the result of comparison of the key of the node with the UID of the authenticated user. Now, making a reading request to a node that has as key the same UID as the current authenticated user would be successful assuming that it exists in the user's reference. Let's try to access another node, but with a key different than the currently authenticated user's UID. Here's another example of using wildcards. Let's say we want anyone to be able to update every node of the user's node, only if the key of the node contains the string mn. Now, if we want to send an update request to the class mn node, we will be able to, because the node name contains mn. But if we try to do the same with the class ab node, it won't work. Rules cascade, which means that if we set a rule in a parent node, it will overwrite the rules in the child node. Here's an example. As you can see, we didn't set any rule in the user's node, which is the same as setting false as read and write to the node. And we have read is true in both of the child nodes, which means anybody can read from them. Permission to read is denied. Why? It's simply because no rule is set to the parent node, even if the child node's read rules are set to true. Now setting the read to true in the parent node will make the data readable from both of the child nodes, even if we set the read rule in them to false. What if we want users to be able to read from one child node and not the other? This is kind of paradoxical because of setting the rules in the parent node. Either we can read data from all the children or deny the reading from them. To solve this, we need to set the read rule to false in the parent node, so we guarantee that nobody can read data from the class B node. And then, to access data in class A, we need to reference to it specifically in the query instead of referencing to the parent node. We can use data at other parts of the database as criterion for the rules. So, let's create the following database and write this rule as example. Let's break down this rule condition by condition. First off, we need to satisfy the first condition, which imposes for a user to write in the user's node that the root of the database has to have a node child called allow rights that has true as value. As you can see, to reference to the root of the database, we used the root predefined variable, the child function, to look for a child with that given name, and val to check for its value. Let's fix this and check if it works. Permission still denied, so let's look at the second condition, which requires that the parent node of the node that we want to add has no child node called read-only. We want to add data to the user's node, which means that the predefined variable data reference to the children of the user's node, which leads us to use the parent method to reference to the user's node, and again, use child with the exists method, which will indicate if this child exists or not, which it actually does in our database. So, again, let's delete the read-only child and try another test. It still doesn't work, so let's take a look at the third condition. Now, the third part requires that the new data to be added to the database should have a node called new, so let's add it. And now everything falls into place. Validate will check if a user wrote the data in a specific way, so it will accept it, or it will refuse to add the data to the database even if the right role is set to true. In this example, if someone wants to write to the database, the data can contain a name node or a phone node or both. However, anything else which represented by the wildcard will not be accepted. Another example of how we can validate data using the predefined variables and methods. So, with this rule, the new data must have two children called fname and lname. Now, we want also the value of the fname node to have more than 4 characters using the length function. Let's add another condition which imposes that the age child should have only a numeric value. We can allow nodes to be queried using only a certain query. In this case, a user can read data from the user's node only using the order by child age ordering function and the is equal 37 querying function. Any other query will be refused. In the development phase, you won't need to use the index on rule, which results that when you query the database, all the data gets downloaded and filtered on your machine, which will cause big problems once you have the app distributed and so filled with big amount of data. So that's when the index on comes in handy, using it with specifying which parts of the data you will be querying using the order by child ordering function. All the filtering will be done on the Firebase servers, which will be a huge plus to the performance of your app. Same thing goes with the order by value ordering function, which works on references that contain only comparable values, except that in the rules here, we need to use the dot value for the index on key. This should be enough for this tutorial. Make sure to subscribe and hit the bell notification, and see you in the next video.